This is Devraj. I am pursuing BE Aeronautical Engineering final year in Nehru Institute of Engineering and Technology. We have done a project about wake study on crew module. We are team members of 4 people who have done this project. My teammates are Divyaponni, Harish, Jana, and my guide is Dr. K. Satish Kumar sir, who guided for our project. The abstract is the study focuses on the computational analysis of fluid flow and the wake formation at the rear portion of the crew module. The wake will be formed at the rear portion of the crew module that we are going to analyze using the CFD software, and the model will be designed in the SolidWorks. The introduction. What is crew module? The crew module is a vehicle which is also known as the re-entry vehicle that is used by the astronauts to return to the Earth from space stations after completing their missions. The picture here shows the crew module which is used by NASA, that is named Orion Crew Module. Then we see about the methodology. Methodology, wake study on crew module. How we have done this project? First, taking the literature surveys from different journals and collecting the dimensions from one of the journal which we used as a base paper, and designing the crew module in SolidWorks. We have done analysis in the ANSYS CFD software. Then we have done post processing and we got the results. The results we got are for different angle of attacks and different velocity ranges. The angle of attack ranges from 0 degree to 25 degrees, and the velocity ranges from 20 meter per second to 30 meter per second at 3 different positions in radial directions such as R1, R2, R3, R4, R5. The width of the wake reduces gradually when the angle of attack increases from 0 degree angle of attack to 25 degrees angle of attack. On the other side, by taking all the actual velocity contours with various angle of attack such as 0 degrees to 25 degrees and velocities such as 20 meter per second, 25 meter per second and 30 meter per second, by increasing the angle of attack, the velocity also increases and the wake dissipation length decreases and its intensity of the wake also decreases. These are the graphs we have got in the contours. These graphs are the calculated results which shows that the speed ratio versus angle of attack, the dissipation length versus angle of attack, and wake width versus angle of attack. In speed ratio, as the angle of attack increases gradually, the speed ratio of the free stream velocity also increases. In this dissipation length versus angle of attack, when the angle of attack increases, the dissipation length decreases. In wake width versus angle of attack graph, the width of the wake reduces as the angle of attack increases. These are all the discussions. After completing the analysis, we have concluded that at 25 degrees of angle of attack with respect to 30 meter per second of velocity, this region is suitable for the deployment of parachute for safety landing of the crew module on land, or in case of water, we can prevent the crew module from sinking. Thank you.